Why we need signal and system? If you want to be a at the end you will need with some kind of some blocks, some signals, and some circuits at the end. This is the layout we are delivering to factory. Take chip out. For example, here we have one RF receiver. That's a receiver for radio frequency devices. What we have in the input, we have one filter. Since this is antenna, the signal is really weak. It's not detectable. We need to amplify it. On the other side, we want to filter all other signals which are not in our band. So we filter unwanted signal. After that, we should amplify the signal. What is LNA? Anyone know? What does LNA stand for? Have you ever heard? Here, signal is really small. I should be really cautious that I won't miss the signal. Every block or element I add here, they have noise with themselves, which means they are adding the noise to the signal. So I should be cautious, so I need to use low noise amplifier. So since the signal is small. After amplifying, I should bring down signal to the baseband. Where is the frequency of signal? You know how much it is frequency. We usually increase the frequency with modulation. Any idea about modulation? Yes. Yeah. Why do we do modulation?
Transfer or saving for the distances.
In fact, it's easier than the signal with lower frequency for long time. In fact, we are using modulation. We call it modulation. We have a signal output. Band is 4 kilometers. Yeah? But how much is the signal, for example, GSM mobile? Around 1 gigahertz or 2 gigahertz. Which means we are increasing frequency to 1 gigahertz or 2 gigahertz. Why? Because of antenna. The antenna can only detect the signal in the range of its length. For example, how much is the length of antenna in your mobile? Suppose it's 10 cents. The signal one antenna can get, the wavelength should be in the range of its length. For example, what is the wavelength of a signal? Speed without light. Over 24 frequency. Definitely. The over lambda, which is over 10. It should be around 3 gigahertz here. 10 centimeters is 0.1, and it would be 3 multiplied by 10 power of 9, which is 3 gigahertz. Which means one antenna with the length of 10 centimeters could get frequency in the range of gigahertz. Okay. If you have a signal, for example, in audio band, which is around 20K. How How big will be your antenna? Okay.
0.15 millimeter.
Millimeter. Oh.
The length we divide it by the
Yeah, 3 multiplied 8, 20.
20 times 10 to the power 3.
Exactly. Around 5. Which means 15 kilometers. That's true. You know, if you want to send your voice signal without any modulation, you need an antenna in range of 15 kilometers. So how can you do 15 kilometers impossible? Yes, that's why we have to increase the frequency of the signal which our antenna could receive it. After that, we send the signal. Here it's a receiver. We have a signal in frequency of 100 gigahertz. And we should bring it down. We use this element, you will learn it after as a mixer. And we have another filter, which is image reject filter, that right now you don't have any idea about that, but you will learn. My point is, we have these blocks as a filter. You should be able, for example, if I'm talking about image reject filter, you should be able to know what I'm talking about, what kind of signal in which domain I'm talking about. Yeah. So you should be able to analyze frequency domain, time domain, and even after that, we should be able to analyze, for example, I designed this circuit, but at the end I see that's it's populating. I should be able at least to find what is the source or what can be the source. Maybe we never can find the main source, but we can go through and have an intuition how we can solve the problem when we have a big system of components. That's why we need to learn signal and you will see why did you learn circuit theory? This is one amplifier. Right now, probably you don't have any idea how you design or analyze this one. Yeah. But the method is again we will use KVL and KCL to find its gain, its input impedance, and all the parameters. Okay, let's go to it part. That was why we needed to study signal and system. The materials we will cover is only a continuous time, but we are not dealing with discrete time. We just focus on continuous time. At the beginning, we will see the LTI system. Anybody have any idea why LTI system? Why we go through LTI? You will see after we have different kind of system, linear, nonlinear, and linear. Why we are interested in LTI system?
Easy to deal and easy content.
And figure it's kind of true, but I think other way I don't feel it. Do you have any idea about convolution? Have you heard about convolution? Yeah. We can use convolution only in LTI system, which means in LTI system, if you only know the impulse response, you know the responsive system to all inputs. Okay. That's why we are looking to deal with LTI system. After that, we will go through Fourier transform and Laplace transform. One of them takes us to frequency domain, another one in S domain. We use Fourier transform for dealing with signal in the frequency domain and Laplace transform to deal with system and checking the stability. Okay, let's go through an introduction. After that, again, we introduce some important signals in the circuit theory. Here we will go through again because I think we need to know what are those signals and how we can deal with them. After that, we will talk about transformation of independent variable, some common properties of the signal, and what is a signal in general? A signal in generally the variable that convey a function of variable that convey. We have different definitions for signal. The only important thing is it should have one information inside. It should deliver one information. We call it signal. And system, that's what organized entity that they're gonna analyze the signals, and for sure they have one purpose or goal to do. I told you why we need to study signal and system in ICT, but in general, at first we should be, when we are studying signal and system, at the beginning we are able to simulate and analyze the system. After that, we will be able to make another system like that. When we make another system like the original one, we will be able to improve it, and we would be able to predict the future signal on the system. I think example of signals like voltage. You had the course, I know should be really fast. Audio signal in the time domain, you can see. Especially for audio signal, we have no idea. But I will show you after in the frequency domain, there is too much information in the complicated signal. The signal picture, the difference is the signal of ECG or audio. They all have one input or one independent variable, which is time. Here, how many independent variables do we have? In the picture, what are the inputs? In the picture, each pixel has one X and Y, which means you should show each one two inputs. So here we have two independent variables, and what is the output? The output, we will call it as the intents of the color, gray color, for example, which is the value depends on how we digitalize that. Again, we can have different signals, random signals like noise, that makes it signals we know, like so that. We can have one-dimensional, multi-dimensional, which in this course we usually focus on one-dimensional, which means we have only one input, which is time. And again, we can have continuous time, discrete time, and digital signal. Continuous time is when our independent variable is continuous, like time. What is discrete time? The independent variable is discrete. Like what? I wrote the segment. Can you give me another example?
The bits 0 and 1.
Yeah, that's, when we are talking about 0 and 1, that's dependent variable. Yeah. 0 and 1 regarding to what? You know what I mean? You are saying, okay, this is a signal, it can be 0 or 1. But what if it's time? Your independent variable is time, which is the same continuous time. How we go from continuous to discrete? So, sampling. We can sample and we will have discrete time. Now, if we have n here, 1, 2, 3, we cannot have n 1.5. It should be only the discrete value. Like stack index. Over days, you have day 1, day 2, you never have day 1.5. Digital system, in digital system, the dependent values are also integer numbers. They cannot be, for example, 1, should be only integer 1, 2, 3. These are the example of continuous and discrete time. Since you know all of them, right? And even go to some important things. What complex exponential waveform? If we consider C a real constant and F a complex number. Yeah. If S is a real, if we have e to power of 20, 5 e to power of 1, you know how deal with this. That complex real. This one is growing, this one is decaying. How do you find which one is growing, which one is decaying? Sign of the coefficient. If it's negative, it should be decaying. If positive, it should be growing. What happens if F is purely imaginary? We reach again to this definition. And after this, we are dealing with complex numbers. I think you should be able to work with complex numbers. It doesn't matter you are using calculator or your handwritten. The only important thing is you should be able to understand. For example, if I'm saying I have a number with 2 plus 2j, if I ask you how much is x, you should be able to say how much it is.
And
How much?
root 8 and the
Should be it. Then if this is a, this is b, it should be a2 plus b2, which is a e to power of tangent inverse of b over a is 1, which angle has tangent of 1? 45. 45 or p over 4. amplitude would be 5. To be minus
39.39.
39.
Minus 50.
Yes.
And 7.
Yeah, you should be able for the how this signal e to power of omega t is a periodic signal. Like because it has cosine and what is the period of one cosine or sine? T 2 pi over omega t. Now we are going to see, I want to show you. For this course, we are using this uh, simulation area, which is pathing. Let's see what it has. It has some sources that you can use constant, so the and it has some transfer function blocks, it has some algebraic blocks we can use to become more familiar with with signal analysis. Do you have your tablets here? I think you can try this with me. Even with your phone. As president, we want to have so, and we want to see its output, how would be its waveform in time domain. We need on oh, how what are the parameters of the sinusoidal source? It has frequency, amplitude, and phase. Suppose here we have frequency 1, amplitude 1, and I go through the simulation. If it's simulated, we can see here the result. Right now, I'm simulating until 10 seconds. You can change it here if you want the duration of your simulation and time step. How much is amplitude of this signal? What? How much is it average? It's zero. Yeah. What is the definition of average? the area under the waveform. Yeah. The area under the waveform. This area is exactly the same as this area. This is positive, this is negative. If we add them together, the result would be how much is RMS? What is RMS or effective value? Well, over which means 0.7 almost. Yeah. The RMS of this signal is 0.7. Suppose you want to add another sinusoidal signal to this one with frequency of 3. Can you do that? Add another sine waveform with frequency of 3. Is it still periodic? This waveform is periodic.
Yes.
It is. What if its frequency
What?
how come?
The period, no?
Exactly. If period is from here to here. It is 1 second, frequency 1 over t, which is 1. If I change the frequency of the first one to 2 Hz, what will happen? Is it gonna be still periodic or not? Okay. Is it still periodic? Is it periodic or not? Yes.
It's very.
What is the frequency of this signal? Another example, when you would in one speed. Here you can almost say. Yeah, you had one frequency, one signal The frequency of the first one was 2 Hz. The second one was 3 Hz. Okay. So, what is the exact value for the frequency of this combination? It's close to 1, but the exact value is not just the exact value.
Frequency is 2.
3.8. You know, from here to here is 0 to here almost 1, a bit less than. But we can find the exact value. We have 1/2 and 1/3 for period. 1/2 plus 1/3, which means 5/50 the period, which is almost this value is a bit bigger than 6/5, a bit bigger than 1 Hz. I wanted to this one go by 1 Hz. It doesn't matter what are the frequencies and amplitude. If you add different sinusoidal signals, the answer would be very. I changed the first one to 1 Hz, amplitude 1. The second one, 3 Hz and amplitude 0.1. And I will add one wave pi, 180. Pi is 3.80 equals to 180 degrees. What happened? I added two time signal, but the answer is like triangle, yeah. With two time signal, I created, it's not completely triangle, but in kind of, let me make it more triangle. I will add another time signal. I'm trying to make these angles sharper and sharper. If I add more time signals, I can make them sharper and sharper.
Is it recording?
Yes. So we found how we can make different periodic signals with summation of some sinusoidal waveform. We know it as a Fourier series. Okay, let's continue with sinusoidal signal. You should memorize these three formula. E to power of j omega 0 t should be real part is cosine omega 0 t, if imaginary part is j sine omega 0t. If we want to find cosine omega 0t through e to power of j omega 0t through this formula, and to find sine through the last formula. The difference is 1j in the numerator and these to sine in sine signal, we have the negative sign here and 1j in the numerator. Unit step like what? Unit step like
As it goes to the time 0, it goes to 1 and stays there. The amplitude.
yes, before time 0 is 0, after time 0 is 1. Can you give me one typical example of unit step?
Which
One which you can close or open it and see equal to 0. In general, UFT 1 when FT is bigger than 0, it's 0 when FT is smaller than 0. If we have one U1 minus T squared, when is this value positive, when T is between minus 1 and when T is bigger than 1 or smaller than minus 1, this value would be negative. When it's negative, U should be UFT is 1 when FT is a positive value. Clear? It's difficult for you or
new reductor. We used to like write it u of t plus 1 minus u of t minus 1.
we wish to that you are talking about time shift. Yeah, that's just know U of anything is 1 if that anything is positive. It doesn't matter. The derivation of UT is in part is found. It's unity part, which is one infinite energy in a short period of time. In second, we find delta through part signal. Then we find the limit of delta to 0. Do you remember what was the definition of part? It was between 0 to delta. Its amplitude was 1 over delta. When delta approaches to 0, 1 over delta is going to infinity, and this time period is going to. How can we make delta with? How can I make delta with 1 UT? Suppose I want perfect I want 1 unit step. What should I do to find the delta? Now that one unit step. Then how much is the area under this curve? How much is the area under this curve? It should be 1. For the definition of delta, this area should be 1. When we write, we have 2 delta, which means that area is on the other hand, we know unit itself is integral of unit equal. Here we have one good property, we call it a sampling property. If you multiply delta with anything, what will happen if I have one P and one delta? If I multiply these two signals together, what will happen? Like that. The result would be, it would be 0 everywhere because delta is defined only in one part. So it should be 0 in everywhere unless the where delta is defined in 0. So if we multiply, suppose the amplitude delta is 1, here we have x 0, here amplitude of x. It would be x 0 multiplied by. If I shift delta to T0, this means I'm shifting delta to T0 to here, which means I'm multiplying delta with x at T0. So it should be x at T0 multiplied by and delta AT is 1 over A delta T. Let's see one example. They ask us to draw delta 1 minus T squared. So I should expand this one. It's 1 minus T multiplied by 1 plus T. We know delta AT is 1 half A. That's it. Here, the root of this one is 1. The root of this one is minus 1. Which means the delta is defined in 2 points. When I'm dealing with this is one coefficient. Which means when I'm looking for T equal to 1, this one it should be 2. When I'm dealing with T is equal to minus 1, this one is kind of coefficient of 2. Yeah. I can easily expand these to delta. And the result is I have 2 deltas, one is equal to 1, another is equal to minus 1, and the amplitude is equal 1 over. Is it clear? You understand this? So, you know, delta 2t plus 1. Now I can draw this. How do you find delta T at 0? You know this one, yeah? You put this R1 equal to 0, yeah? And find the root of that. So if I set this R1 equal to 0, it would be
minus half.
minus half. Okay. So which means delta is defined in minus 0.5 with the other one. Am I correct? Am I correct? Everybody agree? Amplitude is 1. Based on the definition of delta. If we define delta T like something, this is our definition. Delta T minus 1, if I shift it 1 unit to the right. Delta T plus 1. This one unit to the left. Yes. How about this one? Okay, let me go to delta 2T. Delta 2T is located at T0 with the amplitude of 1 over. How do we find that? This equation. I will show you at the end of this chapter when I'm talking about time shift and scaling. You will see how we will reach this one. So this one would be 1 over 2. Now how about this one? And I write it like this. I write it here. And I write it like that. Here. I change T plus half to U, which means I have, yeah, should be the amplitude should 1 delta over delta U, and delta U 1 over delta equal to minus 1 over 2, and its amplitude should be 1 over 10. Right now, you just memorize this one and use it. I will show you how we prove that. Another signal is the exponential. Do you remember where we had this signal? Yeah.
The critically down and up down.
Exactly. In RLC again, when we have on inductor, we call it RLC tank. Yeah. When it was under that, we had something there. Yeah, we doubt it there. Oh, let's see how we can generate the signal with path view. It's maybe tricky that I'm going to help you. What we want on time signal, what else?
It's by the exponentials.
It doesn't have exponential proof. Do you see any exponential proof? I didn't. But it has one exponential and one exponential right? Like the it's not input. It gets one input and the output is exponential of, which means is output in e to power of input. Yeah, but this one is e to power of alpha t, not x. How I can generate t? Did you get my point?
You want to make the variable t with the exponential.
Exactly. For example, if I given constant
Okay. Start. Right now.
how would its output a number? If input is a number, its output would be a number. I need to provide t for that. How should I do that?
Find a variable that
Yeah. How variable? How should be the variable?
So
How can we generate t? No. If I can produce XD like this, XD would be equal to T if this is the big one. Yeah. What do you call this signal? That would be for the return input.
signal.
We are looking to generate ramp signal. But again, it doesn't have ramp signal. Empty ramp signal. How can you generate ramp signal through these sources that we have?
can we use integrator?
Sure, yeah, that's okay. We use, what should I use? Integrator of a constant or
Integrator.
yeah, but what input should I use as a source?
Constant.
If I use constant, it's gonna start from minus infinity, which means
Unit step.
oh yeah, you have that's true. Step first, yeah. We know integral that equals and How many? Need to. How can I become one? When you think one, we call it as the oxidation. Let's say we will look at that. One small signal can make a bigger one. How can I make a that big one? I need to
Intensity. The feeling.
amplify the yeah. See, now we have a damping signal like what we had in the circuit after short period of time depend after time it's gonna reach to zero. That's how we make a signal when we don't have enough voltage. This one is about transformation. We want to press the beat. Just 5 minute break and continue. with your friend, probably you have seen these things during your course in signal and system. I will go a bit faster through them to reach to 2 years. For one signal, we can do time shifting by changing the independent variable. If P is positive, which means we are moving that to the right. Like if we have xt minus 1 is, we are moving the shape 1 unit to the right. Xt plus 1, which means xt minus 1, which means b is negative. We move the shape 1 unit to the left. X minus t is reversal, and x reversal to regarding to vertical axis, and x80 is scaling, which means you should scale the t axis. How come? If you have x to t, you want to find x to t, you should divide all values by 2. Okay, which means here should be 1 over 2, here should be 1 over. X t over 2 means you should divide all by 1 over 2, which means you should multiply by 2. Here multiply by 2 is minus 2. Here multiply by 2 is 2. Okay. You should multiply the t-axis by inverse of. If we have combination of scaling, inversing, and time shift. At first, we do time shift. If B is negative, we move to. If B is negative, we move to right. If B is positive, we move to left. After that, we apply scaling, and at the end, we apply time reverse. Here we have, if we have xt, at first we should apply time shift, it's +1. We should move the shape 1 unit to the left. Then we should apply time scale. A is 3 over 2. We multiply this value by 1 over 8, which means 2 over 3. So minus 1 would be minus 2 over 3. 1 would be 2 over. It is clear, yeah? If we had x minus 2 minus 1 for this shape, how would be? At first I should. What should I do?
Take the minus 2 away from the t minus 1. We take it like a common factor.
No. That's not that. I know what you wrote, it's easy way. Just at first do time shift. I know what you wrote, but it could be more further. Just at first we do time shift -1 means
It advances here to the
To-
positive side.
right side. I need to move this shape to right there. Here would be 1, here would be 2, here 3. This is xt -1. Then I should apply which one?
1 over magnitude.
Exactly. Time scaling. Which means I should multiply the axis by half, which is here would be 0.5, here will be 1, and here 1. At the end, I need to, if it be 2, 2t minus 1. Okay. I need to find it reverse regarding to vertical line. Which means I need to multiply the thing. How about the vertical value? We are only changing when we are doing this. We are only changing the x, the t axis, not the vertical. If I have x t plus 2, which means now I'm doing a vertical axis. I should move this shape.
We will add
Here. Because in the signal, even if it's symmetric about the vertical axis, if you find a point and you continue the mirror, it should be exactly another point on the other side. Or xt should be equal to x minus t. The odd signal xt should be equal to minus x minus t, which means it should be symmetrical about origin. If you find the point, go to origin and continue saying, you should reach to that mirror point. Product of two even signal even. To odd again even, one odd would be odd. Some of them, it can be or cannot. We should find. If we have an arbitrary signal, we can divide it to one even part and one odd part. So, like this one. The definition of even part is we add xt plus x minus t and we multiply the result by half. For odd part, we add xt minus x minus k. And that's just definition. As an example, if we have if xt, can you write the expression of xt? xt can you write the expression of xt?
will be minus 2t u of t
You are
minus t.
minus. And
Plus
Plus
t of t.
du. This is u minus t. T 0. If I multiply these two, I only filter the negative part, the left part. If I multiply these two, I only keep the right part. If I add these two parts, I have both left and right part. Okay. Expression. When you have expression, its even part is add xt plus x minus t. Just change the t to minus t here and add them together. It would be the even part for alpha xt minus x minus t. And it will be alpha. You can't see symmetry about the origin, this is symmetry about the vertical. Periodic signals, you know, they are repeating during the time, and you know how to find for sine and cosine. T. If I give you cosine T, ask you how much it is failure. What would you say?
Pi.
How much?
Over.
2 pi over x. T 2 pi over coefficient of t, omega 0. Here, 2 pi over what coefficient of t is factory 1. 2 pi. How about tangent and cotangent? If t over omega 0 in tangent of 5t it would be the period is 1. How much is t? Period is 5, 20. Period is how much is it? How much?
1 by
1 is pi over 5 pi. 1 over 5 point 2. The average of the signal is we should take an integral if it's periodic in one period, it's not periodic from the whole t axis. How much is the average of the signal? Two. Up. Up. How about other? Let me write. That periodic, I'm gonna take integral from 0 to 2, so it's periodic to 1 over 2. But it's only defined between 0 to 1. So I have 1, 0 to 1, and it's amplitude 1, G 1 over its area is 5. We should divide it by the period 1 over 3. I change it like this. 1 point. How much he gives you up for average of the signal?
0.2.
0 point, which we need to take integral. How much is this area? 0.2 divided by the
T.
period. Yeah. T is how much? It's period is 1. So this value is point. If I have something like that. How much is average of this signal or density of this signal? How much is this area? Half over T. How much is T? So the DC value of this signal is 1, which means if I stop this signal with the amplitude of 0.5, the DC power they can deliver is the same. And the RMS value or root mean square. Root mean is again average and square, which sometimes we call it as the effective value. How much is RMS for sinusoidal?
0.
0. I have a cosine waveform. I want to find in root mean over 1 over E sine E. So I want to find the integral. We don't know integral of cosine power of 2. What should we do? How do we find it? Integral.
Use your 1 minus cosine 2
Exactly. We should make it linear. That it has power of 2. We should make it linear. 1 E cosine of 2 omega t over 1 over t. 1 over 2. Let me write the I have et integral of the constant t multiplied by t, it should be 1 over 2t plus 1 over 2 can come out 1 over 2 integral of cosine 2 omega t sine and integral of cosine alpha t e. Here we have a coefficient 1 2 omega sine of 2 omega from 0 to t. Let me write it. 1 over t. If I write t here, it would be 1 over 2t plus 1 over 4 omega sine of 2 omega t minus sine of 0. Sine of 0 is 0. Sine of 2 omega t. What is omega? Omega 2p over
T.
t. Yeah. I can simplify t, which means sine of 4 pi. How much is sine of 4 pi? 0. So this term is 0. I only have this. And I can easily answer t, which is radical 1 over 2. I had one a, I didn't complicate here. If I write a, it should be a2, here it should be a. And that's the constant. At the end, it would be a over 1 over radical.
Isn't it over? Minus one.
We are looking for positive value. Yeah, it doesn't, it's meaningless when we say, okay, the effective value of 2 volt is minus. We are looking for positive value. Okay, you are right. A can be positive, negative, but for us here it doesn't matter. So when we have a some kind of so that signal 2 volts. How much is this amplitude?
over square root of 2 over square root of 2.
How much is the amplitude? What do we call amplitude of the sine wave? Amplitude is from middle to minus. Yeah, this is A when we are writing A. This A is different. How much is its amplitude? Really?
1.
Why 2? Because A is 1. How much is, if it is a voltage, how much is the peak voltage?
2 volts. P is 1. Peak to peak is
Exactly. Peak is amplitude. When we are talking about V peak, it's again amplitude A. That's 1. When we are writing PP, which means peak to peak, up peak to down. Words is true word. Okay, energy of the signal is we should find its square and integrate from minus infinity to plus infinity. If we divide it by t, when t approach to infinity, if this value is a constant, is a real value, we call it as an energy signal. If it goes to infinity, we should find this one, the power. If that's a real value, it's limited value, it's not going to infinity, we call it as a power signal. If it again going to infinity, it's not even energy or power signal. When its energy is limited, we call it energy signal. When its power is limited, we call it power signal. For example, find the energy and power of this signal. We should find its square. UT means this signal is only from 0 to infinity. I need to change the integral from 0 to infinity. E minus t square is e minus 2t. E to power of alpha t integrally. You get
E to the power alpha.
1 over alpha e to power of alpha t. If we solve infinity, e to power of minus infinity, 0. But e to power of 0, 1, which is energy is limited, so this is energy figure. When energy is limited, power for sure would be 0. Yeah. Here, this value is energy. If energy is limited, which is E over 2t when t approach infinity, would be E over infinity, which is another example. Suppose we have t, which is maximum, okay, t equal to second. Where would be the maximum of x RT minus? It should be t by n. Oh no, I think the concept. Okay, if the maximum value of xt is at t equal to, find the maximum value of x RT minus n. If I suppose x is something like this way, its maximum value is okay as t equals 2. I'm looking to find the waveform from x. At first, I need to move sheet time shift. I need to move the waveform to the right For how much?
N.
N. So T will go to, it was at 2, now it goes to 2 plus N. The maximum of the waveform now is being 2 plus N. After that, I need to apply R, which is the scaling. I should multiply the T by 1 over R. So now its maximum is in 2 plus N over, and its period for T now is T over R. It's gonna be complex. This is another example for sampling behavior of impulse signal. You know, when we have xt multiplied by delta, it's only defined as equals to. Okay. When delta is delta minus 1, which means it occurs at t equal 1. So this is at equal 1. So I need to find x at equal 1. Yeah. I need to find x1. If I replace t by 1, it would be 3. That's the constant. I can take it out from the integral. And integral of delta is integral of delta
Was
1. Integral of anything means its area, yeah? We know the area under the delta waveform is 1. If I had this one, how much is this integral?
Isn't it the same?
Is it the same? When did asking, is it the same? Why you said 0?
But the signal is created
Exactly. I am taking integral from 0 to infinity, from here to here. Where is located the term?
minus.
Minus 1. From here to infinity, we have nothing. It's integral here, 0. From here to infinity. Again, let's see another example. We have 3 deltas. They are linear. We can calculate each separately. This one occurs at T0, it's gonna multiply by T2, which means I need to replace T by 0, so I can omit this one. How about this one? It occurs at -1. I need to replace T by -1. How about this one? It occurs at 4. I need to replace T by the first one 0 and the second one this one. T occurs at -1. I'm taking integral from -2 plus 2, which means delta is inside the area. So this is 1. How about this one? I'm taking integral from -2 to 2, but delta is located at 4. Here I have nothing, so this one is again 0. I have only the middle one, which is coefficient. This integral is 1 multiplied by 2 would be 2. Is it clear? Now we are gonna go a fast review through the system. As you know, we can define different kinds of systems like signal we have, but we just go through continuous time systems with single input, single output. You can see this by yourself. We have different kinds of systems. For discrete time, we may come back after it when we study AD3 and DA3. You know what?
And
Exactly. Analog to digital converter. We will study with them, but before that, right now we don't need them. We are just focusing on continuous time system. We can connect system together in different ways. We can study them. The output of one is connected to input of another one. Parallel, their output and inputs are connected together. Their combination. And the last one, the system with feedback. We taking a sample from output, putting into the input, and we compare it with input. It's different. It's gonna again go to output. We use it a lot in most of the, when you have a system, most things should be like this, right? Suppose you are driving, you have a feedback system. You see the road, you align your hand now to keep yourself between the line. All the time you are getting feedback by your eye and by your hand. Okay. All stable circuit should have one kind of
Doctor, can we stop here today?
yeah, sure. Very forward, but to the left. Feel free if you have any question. I will send you one short assignment. You can solve it in the weekend, but about the signal aspect. That was just if you had exam yesterday. I didn't want to go through Fourier and Laplace. That was just kind of introduction. If tomorrow we will go through convolution and Fourier. Okay, thank you for coming. Thank you.
Yes, Doctor. Can you raise
Sure. Thank you.
I think we've done